most of Great. So there is generally impact put on the monitoring of soil conditions such as I don't know, water flow or moisture or density or and the type of and the type of let's just say engineering values of soil, and based on that. Uh, there is information gauged or let's just say obtained in terms of the safety of such assets such as embankments, tailing dams, or basically infrastructure that is being placed or installed in soil, such as we can see on this photograph. Very, very critical infrastructure such as water dams, electricity plants, probably nuclear plants, but as much as together with other communication and civil infrastructure such as bridges, tunnels. Um, Now the position monitoring places very very important part in the holistic approach in monitoring. Basically, when we monitor position, we basically monitor the state of the soil or state of the asset, meaning that if it's not supposed to be moving, if it's supposed to be stable, but it is moving, and it is moving beyond certain levels of agreed and confirmed and safe parameters such as thresholds. We call them thresholds. Then obviously that can indicate that the monitored asset is prone to damage or is basically unsafe. So this is where we're utilizing the technology of GNSS. On this slide, on the left-hand side, I'm showing an example of GNSS instrumentation. This instrumentation basically relates somehow to all GNSSs that we have in our phones, in our vehicles. GNSS is widely being used in engineering and surveying, mapping, even in agriculture. Recently, actually, GNSS had been as well used in such devices as automated lawn mowers for big cities. So these are all devices that the purpose of them is basically to obtain a position automatically, and based on this position, either navigate a machinery or plants, for example, agricultural plants. Now, what we are using GNSS is basically to gain very, very high level of precision of the point of installation of such instrument. Um, this instrumentation has been used generally in civil and in surveying and in construction for very, very long time. I'm sure that many of you have met or had even probably worked with land surveyors utilizing GNSS equipment for the purpose of obtaining coordinates or setting out coordinates. Our equipment uses the same technique. However, this equipment is being with the difference that our equipment is being deployed permanently in one spot, just like any other type of geotechnical instrumentation. You can imagine GNSS being, which I'll show on for the first photos. GNSS instrumentation is being deployed individually in single spot, and by occupying the spot on some sort of a mount, like as you can see on this photo, or a pedestal, it continuously measures the position, and would there be any movement of ground happening over here, or let's just say over the asset, then obviously the role of GNSS over there is to capture this movement, measure this movement, compare this movement with the allowed thresholds or allowed limits of the movement, and then basically basically by this comparison inform us or warn us would there be unsafe movement horizontal, which means flat movement on the, let's just say on we call that on X or Y axis, or vertical, which is basically settlement. Now, this instrumentation I mentioned before has been used in surveying and in monitoring for a very, very long time. However, its biggest problem lies with its size, with its complexity, and as well with let's just say the affordability of this solution. These devices are generally quite big, quite hard, very, very power hungry. They require several different components responsible, for example, for powering, for regulating the power, for communication between several instruments. So it's generally the GNSS system works on at least two pieces of instruments, which we call them a base and the rover. There has to be communication remain between them. So it is quite complex instrumentation, and till now, this instrumentation has been deployed only in the most critical situations. So let's just say type of deployments, such as water dams, as I shown above, or massive slopes, where we're talking about the highest level of let's just say investment in terms of monitoring and creating an automated and self-sufficient autonomous monitoring system. This is how our device looks like in comparison to the previous one that you saw in the photo. It is just under 2 kilos of weight together with the batteries. It is, as you can probably imagine, it is very, very easy to deploy. It is very, very easy to assemble. And together with the programming part of it and setting up part of it, it is very, very easy and very, very flexible to be basically put in place by the geotechnical specialist. We made it basically to measure subsidence and heave, slope stability, settlement. However, as we can see right now, our instrument being deployed out in the space, engineering, surveying, and geotechnical space, it is basically as well mm, uh, applied to such monitoring aspects as infrastructure, bridges, tunnels, sometimes buildings, structures. Um, uh, so it has been very, very widely used. I'm going to talk a little bit more about right now about GNSS technology, how basically our unit operates. This is a differential GNSS unit or system, meaning that it uses permanently occupied base and stable base, and the positions of monitoring points are obtained in regards or in relation to that base. So would you need to monitor 20 points or 20 locations? You would need to have 21 instruments at least, meaning that you would have 20 rovers plus one instrument deployed as a base. Our GNSS meter uses the same type of hardware for both. So in this regards, it's very, very flexible. So how do we do that? The entire system obviously works outdoors. It needs to be deployed in the area when it can capture as much information from satellites as possible. We're talking over here about open sky, probably about 75% of it on entire horizon around the antenna. Antenna is the point of capturing the GNSS data, and the square box that you see below, we call that a logger or G7 logger. This is where all the components of the systems, together with batteries, are being kept, and together with our LoRa radio, and obviously the GNSS antenna can be detached, and that is the point that actually that is the component of the system that has to be exposed to the sky, as much as the G7 box or the G7 logger can be stashed away somewhere in another enclosure, or basically being put somewhere more in a more secure location. Okay, so how do we do it? We're using base to acquire and calculate so-called RTK, real-time kinematic correction, and this correction then is being communicated to the group of rovers over LoRa protocol. Okay, so on this slide, we're showing overall idea of the entire network of rovers. So generally, we can see over here how our rovers are obtaining information from satellites, and at the same time we have base acquiring information from the satellites. After base acquires the information from satellites together with rovers, base calculates internally on the device itself RTK correction. This is very important. And then the correction from the base is being retransmitted to our rovers or group of rovers over LoRa protocol. After this is being done, um, uh, I'm just going to mention we using LoRa communication protocol to distribute the RTK correction because this is very, very power efficient communication, or let's just say hardware. Um, Currently, if you would see a GNSS rover in hands of land surveyor, these equipment is basically operating most likely either on UHF radios or GSM communication, cellular network communication, which requires a lot of power. It has massive power consumption in comparison to our devices. However, these are mobile devices. Survey rovers are mobile devices which you basically assemble every day. You travel with them, so you are able to change the battery every 3 or 4 hours. And so in this regards, you don't require a very, very power efficient system for communication. However, our equipment, you have to remember that we made this for monitoring, meaning permanent occupation and permanent deployment. And with this way of communicating, we can assure over 3 years of unattended operation over on one set of batteries. Yes, when after GNSS corrections had been delivered to the rovers, then rovers are obtaining accurate position, and then this information is being again retransmitted from all the deployed devices over LoRa into the LoRa gateway. And then from gateway, all the information, just like with all our load sensing devices, is being communicated from the gateway back to your data depository, data server, to your software. And this happens over cellular network or over LAN cable or directly into your computer or directly into your monitoring system. This is our system as well works without it can be deployed without gateway. We already have this being deployed in LoRaWAN environment where you can utilize as well CMT cloud optionality, and with this there is several other benefits of this. And yes, we have this we have this new optionality to work with our GNSS meter without gateway. Together with this, obviously, we introduced new features in CMT Edge. One of these new features to support GNSS meter is basically GNSS meter configuration. We have that feature being right now integrated together with Google Maps, or let's just say geo-referenced photogrammetry, where after your instrumentation is being deployed, on this tab you will see the location of your GNSS on your site, on your network. Our instrumentation works every hour. So for all of you users being familiar with automated or being specialists of automated in monitoring, obviously there is a sampling rate, and sampling rate of our GNSS is once per hour. This is really important. We cannot make our instrumentation work any more often. However, we do provide the data on the hourly basis together with 6-hour aggregated value and 24-hour aggregated value, meaning that for every current hour of measurement, you will get 3 types of data: 1-hour data, 6-hour aggregated data, and 24-hour aggregated data. Why we're doing that, I'm going to explain a little bit later. Everything is being delivered to your system in very, very simple CSV files. There's obviously as well a way of customizing your reports. However, getting the data from GNSS system into your own platform, into your own monitoring dashboard, it's very, very simple. it is basically the same system and the same integration or import data protocol that you can be using for your load sensing devices. Few aspects, the most important five aspects of our GNSS that I'm going to cover today later on, right now on our session is basically survey grade 3D accuracy. So GNSS overall accuracy of obtaining position is several millimeters. Okay, we manage to by aggregation of the data, we are managing to provide this the level of accuracy of our GNSS to 2 to 3 millimeters. High resilience autonomy, I mentioned that already. Our GNSS operates on batteries which are replaceable, and that we have already over 3.5 years of permanent deployment on a single set of batteries. However, there will be more aspects of this that I'm going to cover later on. Long range and network reliability. You can deploy our base and group of rovers on significant area, and paired up together with LoRa communication between our GNSS nodes and world sensing gateway provides a very long range of deployment of the instrumentation. Operational simplicity. Yes, we made this equipment easy. We made this equipment catered for you, geotechnical specialists. So you do not need surveyors, you don't need IT specialists or software knowledgeable people in terms of data processing, 3D data processing, in order to use our equipment. It is very simple. And obviously, this is part of our part of our world sensing, load sensing device, which allows us to combine your instrumentation in different complete solutions, such as slope monitoring, combining GNSS together with IPIs and our digital nodes together with our tilt nodes. And everything works basically on one standard protocol and communicates to the same gateway. Um, I'm going to elaborate right now on those 5 points a little bit more. Accuracy. At this moment, I would like you basically to have understanding that our GNSS equipment can operate up to several millimeters accuracy. That depends on various conditions of deployment. Obviously, this is a system that requires communication with GNSS satellites, and obviously satellites are moving in various parts of the day, various longitudes and latitudes of the globe. There is better or worse coverage of satellites. However, when we tested our GNSS in the most favorable conditions, we can guarantee that those accuracies presented over here in this chart. The accuracies basically depends on few factors. One of them would be the distance between base and the rover, hence why we present this value in two scenarios. One scenario having very short base vector. We mentioned it over here for 40 meters. However, these accuracies you can gain with the base and rover deployment on the distance anywhere in between 40 meters up to 1 kilometer. And then on 4 kilometers, this is the maximum range or maximum distance that we recommend for our system between base and rover. Your accuracies will be, I would say, by several millimeters lower. I mentioned already about the battery resilience, so about the battery life. However, these are not the only, they're not only the most important key aspects of our instrumentation. One of them, which is very important for permanent employment in various conditions, especially in your region, which is quite humid and hot, is basically operation or the operating temperature. Our instrumentation is being tested to operate in temperature range from -40 to +80 degrees, which basically makes it very reliable and very resistant to work and operate continuously. in temperature about like in your region, plus IP68, which basically makes this instrumentation very safe to work in very humid and let's just say very rainy environment. Plus, we can offer or we can come up with a special ways of enclosing the system with special enclosures that can seal it from salt water ingress. But these are very specific applications that we can discuss already based on the application. And obviously, our instrumentation is as well very rugged, and can take a fall from over 1 meter. All of you, our users of world sensing devices, are familiar with our world sensing app on Android, and the way you basically maintain the data and use our equipment. This is the same way we do with GNSS. You will not need anything else but a mobile phone with world sensing app in order to work with our GNSS meter. I mentioned that before. This connectivity range and connectivity conditions, we do limit communication between base and rover. We not limit it, but we recommend it up to 4 kilometers. However, there is a lot significantly higher and just a regular standard range between nodes, GNSS nodes, and gateway, which can be obtained up to 15 and above kilometers, depends on the environment of deployment. And this is very important part that I would love to touch with you maybe later on if I will have a little bit more time, or would you like to contact me later after this presentation? Wide portfolio integration and scalability. What does that mean? That basically means that our instrumentation is very easy to scale, meaning that every single instrument can work as a base and as a rover. Meaning that if you would have, like I mentioned, 20 pieces of GNSS meter, you can have that being deployed on 3, 4 sites or on one site, having 1, 2, 3, 4 bases, or just one base and 19 rovers, just because this is the same hardware for base and rover. As well, we do provide vast range of solutions for geotechnical monitoring, and together with that, you can basically create very innovative ways and chains and combinations of data, spatial data, together with your geotechnical data. One of the examples can be combining GNSS that will provide you absolute elevation measurement of absolute elevation. You can have that combined with the extensometer, or you can have that combined with the in-place inclinometer. That will basically allow you to gain your profile from your IPA a lot more accurately, or basically have that being deployed completely in the completely different manner, from the top, from the bottom, from the top to the bottom, and on the top you would gain your point of reference. Now, this is a few examples that I would like to share with you. This is a big deployment that we already are having, one of the first deployment of our technology up in Sweden. This is completely different environment to one that it's familiar with you, I know. However, this is very challenging and very, let's just say, testing area for our equipment, just because of the high temperature. As you can see over here, vegetation, big spread of instrumentation, spacing of instrumentation, and obviously the challenge over there is generally this is a mining activity where we monitor various and very broad spectrum of assets, such as tailing dams, open pit mine slopes, together with settlement of the embankments for the highway that is basically surrounding this mining activity. I would love you basically to spend a little bit time right now just to reading out those questions. Maybe some of those questions will resemble a little bit closer with you and your necessity and your requirements in terms of such instrumentation as GNSS. What we aiming to present today and to encourage you, geotechnical specialists, basically to um, to have open mind into basically introducing 3D spatial or 3D monitoring, position monitoring into your geotechnical applications, and uh, uh, to to be aware that right now this technology is being available to you within the reach of your hand with very, very little input and very, very little training, and it is quite, let's just say, I wouldn't say affordable, but basically it is very feasible in terms of bigger scale deployments. Yes, thank you very much for your time. Ms. Amelia, do you think that this is time right now for questions and answers, or we leave that for let's just say for later on?
Okay, Michelle, thank you so much for your explanation. Such a great explanation from you. Sepertinya kita berikan satu kesempatan pertanyaan ya untuk rekan-rekan yang ingin bertanya. Boleh raise hand atau mungkin bisa menggunakan media chat sebelum nantinya kita akan masuk ke pemaparan dari telematika asset monitoring. Oke, sepertinya ada yang raise hand, Mas Prima Laksana Bramantio. Oke, silakan Mas Prima.
Oke, terima kasih Mbak Ruth. Eh, Hai Michal,
Hello there.
my name is Prima. I am a geotechnical engineer in Arutmin, coal mining company in Indonesia. We have several monitoring device such as radar, extensometer, and also prism monitoring. I think it's a new device for this GNSS meter and a new knowledge for us. And we want to know about the weather interference on your device. Is it affect the data or the data transfer on your device? Because in radar, we also have the atmospheric uh, disruption, and, and in our prism monitoring also it is limited by our total station
Yes, Prima.
capability. Yeah.
Yes,
Yeah.
Prima.
So I want to know about the weather interference, and we have also a critical area, which is the distance to our radar is 1800 meters. I want to know about the uh, what you call this specification or accuracy on your device, and also I want to know about the software requirements. Can we use a web base and kind of we log in into that website and to see in the graphic or the display of the movement, kind of something like that?
Yes. Yes,
Yeah,
Prima. Thank you
thank
very
you.
much for very valid and very relevant question. Um, uh, we are let's just say we are within the same understanding of this technology. So radar monitoring and prism monitoring, automated total station monitoring, and GNSS monitoring, they lie within the same with the same type of instrumentation, meaning that they do provide information about space, about coordinates, about deformation, about movement, about settlement. Let me just try to right now bring up another slide, which I have prepared. Okay, so yes, so in terms of GNSS monitoring and prism monitoring and radar monitoring. Um, uh, Yes, radar monitoring and prism monitoring, total station monitoring are optical methodologies. So they basically use optical way of obtaining the distance and the angle from your instrumentation to the prism. This is very good technology of obtaining coordinates. However, yes, together with longer distances and together with, let's just say, changing weather conditions, it might be quite difficult and might be quite troublesome. Um, what we offer with our GNSS solution, we in this way, let me just worth it's worth mentioning at the very beginning, the GNSS technology in general is very independent from any weather conditions. So would you have a night, day visibility, or clear sky, or fog, or rain? GNSS will perform equally. There is no optical need for the communication, or let's just say visibility in between base and rover. So which basically needs to be present for your prism monitoring, uh, as well as for your radar monitoring. Now, radar monitoring, I never actually deployed radar monitoring technologies. I'm a land surveyor, and I'm well aware of radar monitoring being deployed more for mining slopes, or let's just say surface
Yes,
monitoring.
right.
And this technology it's crazy expensive in terms of actually
Yes,
hardware. So companies that are basically providing such services, they would rather hire you in instruments such as radar. And then again, these are very power hungry, and very power hungry technologies. They're not they're not technologies that you would utilize permanently. You would probably or you would have to provide some sort of a source of power, such as generator or solid solar panels. Overall, if I would compare GNSS technology and total station, they do provide comparable results. As much as we can argue over here that half a second total station, a robotic total station, can obtain position down to 1 millimeters accuracy, there's many factors in between, resection, measuring to your control prisms, and then basically making rounds, together with actually changes of temperature and changes of ambient temperature, that basically will create then later on these difficulties in terms of total station monitoring. Now, again, total station monitoring is very good. You have one major investment in as a total station, which is crazy expensive, and then you deploying your prisms for on the points that you want to monitor. This prism, obviously, this is a technology that can be you obviously utilize underground. This technology can be utilized indoors. GNSS has to be deployed outdoors. So this is the major difference and major, let's just say, cutoff point where you would probably try to subsidize one with another. However, just like I mentioned over here, with the GNSS, with our GNSS solution, the investment level for single piece of instrument is very little in comparison to total station. So let's just say for one total station, you can probably deploy around 20 of our GNSS devices. So this is where we're getting into the stage where actually GNSS technology becomes affordable and becomes financially probable and optional. I put over here a few information about GNSS, let's just say about total station monitoring. Um, Now I just want to basically, some of those facts over here are well known. Main challenges with total station, basically it's very expensive and it's prone to be vandalized, or the cost of losing total stations are massive. That's what happens over here throughout Europe and the United States. Total stations are being either vandalized or stolen, and this is, let's just say, the heart of the system, which once being damaged or basically vandalized, it has to be replaced, and the entire system fails. However, with GNSS, you only destroy one point. You only destroyed one instrumentation. And again, GNSS or total station monitoring or prism monitoring, it's very hard to redeploy and very, very hard let's just say, suit to the situation. So once it's being deployed, once you localize your control points, your localization prisms, or your points of reference, it is very, very troublesome, and it's very, very hard to then change the position of the total station. Would you need to add, or would you need to expand the area of monitoring? Now, the most viable solution over there is basically adding another total station, which again is a massive cost. So what we can offer in terms of total station monitoring, we would never offer replacing one system with another. That is just basically not very smart idea. You have probably the entire system, but however, we can provide additional points. We can provide ways of providing redundancy measurements, or we can combine, we can integrate GNSS together with total station, providing extra level of information for control points and for monitoring points. Prima, you ask as well about software. Our system
Yes.
does not require any software. Our system
Okay.
does all the calculations, all the computing on the hardware itself, and where you obtain your data, when you obtain your monitoring data, you have there already calculated displacement. So you don't need to run any software that will do let's just say adjustment, or basically Rhinex files processing. We give you already a data, and this data is being calculated on your devices. There's no third party or no other software that sits somewhere outside of your devices that takes part in the computation, which is very, very important. That means that your data does not leave your infrastructure, your monitoring infrastructure. It remains its very, very agnostic approach in the data processing, together with the fact that there is no operational costs. We do not support OpEx model of business, meaning that there is no subscription fees with our devices. When you buy our equipment, all the computation is happening within the equipment inside on our edge.
Okay, okay. So it did not require any software to download the data.
No, it does not. Does not. What you get, you download your data from your gateway the same way you would upload, you would basically get the data out from your geotechnical sensors. And we provide a CSV file as an output format for your GNSS data, for your spatial data. And CSV file is the most, let's just say, the most common and most easy type of information, or like text file that you can then import into your platform, into your monitoring platform, on your monitoring dashboard.
Okay, great.
Yep. And coming
And
back, coming back to your question about um, radar.
the
Radar
yes,
is a solution that provides you an aerial monitoring and it gives you a massive cloud of data. And our
yes.
approach is monitor points rather than the entire area. And obviously, radar monitoring requires a lot more than only a radar.
Yeah, actually we have several critical areas and we have only maybe five radar and we need more monitoring tools to cover the critical area. So I think the GNSS can be used to monitor on our critical area, implementing the completing the existing monitoring tools that we have. And about the radar, it is yes, you are right. It is an aerial monitoring tools, but it has also the limitation. If we install it too far from our critical area, it will become
Noisy.
unsensitive to smaller
Yes.
Yeah,
The smaller
yeah,
movements, yes.
the atmospheric,
Yeah.
yeah, and not sensitive to smaller movement also.
Yeah. And
When it's
would you,
raining and the radar is the data is not good.
and Prima,
Yeah.
just a quick question. Would you have as well problems with vegetation in terms of radar monitoring?
Yes, that's also the water also. Water runoff when it's raining and the data from the radar is not good. And
Yes.
so, yeah, I think it's a solution for us if we can install the GNSS meter on our densely vegetated area. And I also want to know about the accuracy of the GNSS. We have a critical area that the distance is 1800 meters. And how about your device when it installed on that range for the accuracy?
Yes. Yes. Well, your total station would basically not perform very well on such a long distance.
Yes, that's
Normally,
right.
normally with automated total station, you would try to limit yourself to gain higher accuracy and reliable readings, which are not impaired by rain or fog or significant changes of weather. Meaning that you will have repeatable readings and comparable results. You want to limit yourself with the distance of 200 to 500 meters, which is not a lot. It's basically one third
Yeah.
of what you are doing currently.
Yep.
But yes, these are the limitations of total station. And
Total station.
yes, I'm very well aware of that. With the GNSS, there are some other consideration that needs to be taken into place. However, within one kilometer, let's just say on 2 kilometers on 2 millimeters distance between base and rover, you can expect around still about 3-4 millimeters or maybe 5 millimeters accuracy in
Okay.
terms of elevation. So horizontally, you can expect probably about 4 millimeters accuracy and then about 5-6 millimeter accuracy in terms of
Okay.
elevation, which is from my perspective, considering the changes of temperature, humidity, um, uh,
Yeah.
and basically long ranges, it is comparable. By all means, it is comparable results with the GNSS and with total station.
Yep. Thank you for the answer, Michelle.
By all means, Prima. And if I could suggest, in these areas, would you like to actually have a fair trial? You can basically install both at the moment and just compare the results, basically having the data redundancy, and obviously later on maybe limiting that to only one solution, or just basically having a little bit more experience, gaining some knowledge and experience from this deployment. We
Okay.
really encourage our users basically to have a go with our instrumentation, with our GNSS meter, especially right now when it's still instrumentation that is relatively new to the society of geotechnical engineers and specialists.
Yeah, it will be great if we can try the GNSS meter and on our side, right, Miss Ruth?
Terima kasih Mas Prima atas pertanyaannya. Thank you so much Michelle for your answer. Sedikit memfasilitasi dalam bahasa Indonesia. Jadi memang teknologi yang ada pada saat ini, terutama untuk deformation monitoring, itu sudah sangat banyak sekali. Dan memang pada akhirnya teknologi itu akan saling melengkapi, memiliki kelebihan dan juga kekurangan yang sama-sama saling melengkapi. Dan dengan berbagai jenis teknologi monitoring tersebut, banyak juga tantangan seperti tadi yang disampaikan oleh Mas Prima, seperti vegetasi maupun cuaca, yang itu nantinya juga bisa melengkapi satu sama lain. Dan nantinya pun juga bisa dikomparasi antara GNSS meter maupun dengan robotic total station ataupun radar. dengan pemaparan dari Michal tadi bahwa keakurasian 3-4 mm atau dalam skala milimeter itu cukup membuktikan bahwa GNSS meter ini sangat baik adanya untuk mendukung deformation monitoring dan juga memberikan informasi 3D. 3D dalam ini adalah memang secara positioningnya jauh lebih lengkap. Dan dengan perubahan atmosferik, temperatur, humidity itu juga menjadi pertimbangan yang nantinya bisa menjadi um, melengkapi kebutuhan dari deformation monitoring menggunakan GNSS meter dari world sensing. Sebagai tambahan, kita akan masuk ke sesi berikutnya yang akan dibawakan oleh Noval Anhaer yang akan banyak memberikan informasi bagaimana GNSS meter ini sudah dideploy atau diinstal di Indonesia. Uh, Nova Anhaer, time is yours.
Baik, terima kasih atas kesempatannya dari Marut dan a very interesting presentation and very interesting technology about uh, Michelle presentation. Dan selanjutnya sedikit melengkapi terkait sebenarnya apa saja sih yang sudah sempat diimplementasikan oleh kami. Di sini saya mewakili sebagai engineer dari Telematika Asset Monitoring dan akan mempresent sedikit terkait ya experience case yang sudah dilakukan oleh kami dan untuk implementasi yang sudah kami lakukan khususnya di GNSS Meter ini ada di salah satu eh, perusahaan mining di Indonesia. Sebelumnya, sebelum masuk ke proyeknya, kami paparkan sedikit terkait workflow atau sistem yang kami gunakan, monitoring system yang kami gunakan dari GNSS Meter ini. Jadi kami kolaborasikan GNSS Meter ini dengan Trimble 4D Control. Trimble 4D Control ini atau yang biasa disebut sebagai T4D adalah suatu software dari Trimble yang mana digunakan untuk memvisualisasi, untuk melakukan berbagai analisis, untuk melakukan reporting dan juga alarming. Jadi kami kolaborasikan berbagai sensor, khususnya pada saat kali ini kita bahas GNSS meter dengan T4D itu sendiri. Jadi untuk GNSS meter di sini berperan sebagai sensor sekaligus sebagai istilahnya logger. Jadi sensor dan pengambilan datanya sudah include pada satu alat, satu unit, yakni GNSS meter itu sendiri. Kemudian juga dilaksanakan sistem RTK, yakni digunakan satu base dan beberapa rover, yang mana titik rover ini yang digunakan untuk monitoring, titik yang dimonitor. Kemudian sebentar. Ya, kemudian dikolaborasikan dengan gateway, dikoneksikan dengan gateway, yang mana gateway tadi sudah dijelaskan juga oleh Michal terkait koneksinya menggunakan sinyal LoRaWAN atau Long Range Wide Area Network atau atau bisa disebut sebagai gelombang radio. Nah, dari GNSS meter kemudian kami koneksikan menuju gateway dan kemudian dari gateway akan terkoneksi langsung menuju public internet yang mana bisa dikoneksikan dengan GSM atau dengan eh, router atau kabel koneksi LAN sendiri. Kemudian dari gateway itu sendiri sudah bisa dikoneksikan langsung ke T4D. Nah, kemudian untuk project yang sempat kami implementasikan ini ada di salah satu mining yang cukup besar di Indonesia. Di sini kami mengimplementasikan 11 unit, yang mana satu unit berperan sebagai base dan 10 lainnya menjadi rover atau titik yang dimonitor. Di sini khususnya ini kami implementasikan untuk keperluan tailing, untuk monitor suatu tailing, yang mana dengan latar belakang tailing ini memang cukup ada eh, potensi resiko deformasi. Nah, kemudian ini adalah salah satu visualisasi data dari GNSS Meter yang kami implementasikan. Bisa dilihat di software T4D ini dapat terlihat grafik visualisasi eh, yang didapatkan dari data-data koordinat setiap GNSS-nya. Di sini kami tampilkan 5 GNSS, 5 unit GNSS, dan tiap unitnya menghasilkan grafik masing-masing. Dan dapat dilihat di sini salah satu fitur dari T4D dapat eh, menginput plot band atau kelas. Dapat dilihat ada kelas berwarna hijau, kuning, dan juga merah. Di sini kami golongkan menggunakan term hijau sebagai normal, kuning sebagai warning, dan merah sebagai danger. Dan ini dilakukan penyesuaian ambang batas yang mana disesuaikan dengan kebutuhan masing-masing site. Di sini kami input 0 hingga 25 ini masih kategori aman, kemudian warna kuning 25 hingga 35 mili ini kategori warning ya sudah perlu peringatan, dan 35 hingga 50 mili itu sudah masuk danger yang mana memang disesuaikan dari kebutuhan tiap site. Nah, dari kelima unit ini dapat dilihat deformasi atau bisa dibilang resultan gaya yang terjadi karena dari data yang dihasilkan memang 3D atau XYZ, kemudian dilakukan perhitungan oleh GNSS meter tersebut oleh gateway dan T4D menghasilkan data deformasi 3D-nya atau data deformasi resultan gaya dari ketiga sumbu. Menghasilkanlah deformasi yang sedang ditampilkan ini. Jadi bisa dilihat ada tren kenaikan sebagai contoh di GNSS kedua, unit kedua di sini ada kenaikan sekitar 10 mili ya dari dalam suatu malam di tanggal 29 Juni hingga 1 Juli. Sorry, 30 Juni hingga 1 Juli. Jadi untuk sebagai informasi juga di sini kami konfigurasi dalam per 1 jam. Jadi data eh, secara periodik diambil, di logging datanya selama per 1 jam. Jadi dapat dilihat kerapatan datanya dan data ini adalah data range dalam 3 hari. Kemudian selain dari grafik ini, kita juga bisa memvisualisasikan secara 2 dimensi dalam peta, yang mana sekaligus juga kita mendapatkan apa ya bukan animasi, kita mendapatkan gambaran arah dari resultan gaya yang dari deformasi yang terjadi. Dapat dilihat di sini eh, dari tiap-tiap rover ini menunjukkan eh, data deformasi masing-masing dengan dari kelima unit ini menggunakan satu base. Yang base ini adalah yang di bawah sebelah kanan di arah tenggara, kemudian 4 lainnya digunakan sebagai rover. Nah, dari data rover ini, dari data peta 2 dimensi ini menunjukkan resultan gaya yang ditunjukkan oleh anak anak panah yang ada di peta. Jadi sebagai contoh, data-data dari yang unit ini dan unit yang bawahnya menunjukkan data yang lebih ke arah tenggara, yang unit ini juga menunjukkan data ke arah tenggara, berbeda dengan data unit yang saya tunjukkan ini, itu ke arah lebih ke utara hingga timur. Nah, ini adalah sebagai contoh dari implementasi yang telah kami lakukan dan bagaimana kolaborasi antara GNSS Meter dan juga visualisasi yang dilakukan pada software Trimble 4D Control. Kurang lebih begitu, sebagai sedikit tambahannya, apabila memang terdapat hal yang perlu didiskusikan dari teman-teman semua, bisa dipersilahkan. Dan saya kembalikan ke Mbak Ruth.
Terima kasih Mas Noval atas pemaparan yang diberikan, sangat fresh apa ya bisa dikatakan fresh explanation dari success story implementation GNSS Meter ini di Indonesia di salah satu mining industry di Indonesia. Oke, baik. Dari rekan-rekan mungkin jika ada yang ingin ditanyakan mengenai GNSS Meter ini sendiri, bisa raise hand atau mungkin bisa menuliskan pertanyaannya di kolom chat. Jika mungkin ada keterbatasan dalam bahasa, tidak masalah dalam bahasa Indonesia, nanti kita akan bantu untuk translate dalam bahasa Inggris ke Michal Dabrowski. Silahkan rekan-rekan jika ada yang ingin ditanyakan.
Ya, Bu, may I have time?
Silahkan Bapak Rahmat Burhanuddin.
Thank you. Thank you, Michael. For monitoring, it is not rare to be implemented in forest. So vandalism is one of main problem. My question is it possible to bury the device? But for example, we install the, what can we say? We install the antenna with one of the other way. Thank you.
Okay, Michelle, I think.
Yes. I was just trying to find the unmute button. Yes, thank you very much for your very, very relevant question. Yes, vandalism and basically damage to any instrumentation that is being deployed out in the open areas. It is a problem. It is a problem. It is a problem worldwide. That does not depend on any region. That does not depend on is it an urban area or quite remote. Vandalism or let's just say even damage can be done by animals. Some like over here in Australia, we've been already told they are like basically dingoes, or in New Zealand there are particular birds. I don't remember the names, but they have this basically ability, or let's just say a love for cables. Anything that is plastic, they will chew on your widescreen wipers in your car. So yes, there's a massive always potential into your vehicle or to your instrumentation to being damaged. Yes, GNSS. I'm trying right now to find relevant photos, which just please give me a second. Maybe I will try to find somewhere over here. Examples of deployments. Our GNSS basically can be deployed as I just showed on the photos before. However, the instrumentation as well. Oh yes, okay, I have it over here. I have it over here. Instrumentation can be as well deployed in a little bit now. Okay. My apologies. I'm struggling a little bit with this, with moving this around. So okay. So on this photo, we can actually see how the GNS antenna GNSS antenna is being deployed together with our unit, and you can have the LoRa antenna cable being detached. Basically, with extension cables, you can mount GNSS and LoRa antenna separately and have them exposed. And then you can have the G7 unit, the logger itself being kept in some sort of an enclosure, which I will try to basically show some photos maybe a little bit later. This is probably maybe something like this. Okay, this is very relevant example of installation. Over here, we have entire GNSS instrument being basically kept under the plate over here on this, and then basically GNSS antenna being installed separately. Now this makes the entire the entire installation very, very remote. Now this is installation on tailing facility where every few months they actually expanding tailing by raising up the banks. So what they do with the entire setup, they basically carry the entire setup, the entire block with the GNSS with the forklift, and they just move it from place to place. They deploy it then on the top of the embankment after they raise the embankment on the tailing, or would they need to rearrange the locations of the GNSS? Now, for this, obviously, because you can have the instruments being detached or let's just say installed separately, there is this optionality to protect your instrumentation in a better way than if it would have been in one piece. However, yes, this is another example on this photo. I just have this little photo over here. However, let me just try to zoom in. As you can see, GNSS base is being deployed on the top while entire G7 unit is installed in an additional enclosure, which is then being locked. And then GNSS antennas over here on the bridge itself being installed on the pipe raising, and then G7 just installed on the pier underneath the deck of the bridge, which is basically very, very secure location. So to answer to your question, is there is several ways of deploying our instrumentation, and yes, that we do as well for certain applications, and for sample for certain installation, we can basically propose a special enclosure, or let's just say special cabling and extra protection, let's just say for water ingress.
Thank you.
Yeah. And another point, if you compare it to total station, obviously we don't want your equipment to be damaged or stolen. However, if something happens with your instrument, you basically carry, or let's just say the only one instrumentation is being damaged or stolen, while with the total station, the damage is it's critical. It's a massive damage to the system, and basically it makes the entire monitoring system basically dead or redundant.
Yeah, excuse me, Michael. So, since the instrument is not power hungry, it means it does not dissipate much of heat. Yeah. So I wonder if we can bury it to protect it, and the antenna is well okay. If someone saw the antenna, the instrument is still there. Thank you.
By all means, you are very, very welcome.
Terima kasih Pak Rahmat Burhanuddin atas pertanyaannya terkait dengan isu vandalisme itu sendiri. Seperti kita ada tambahan pertanyaan dari Bang Dani Paul, seperti ini dari Browcall ya. Bang Dani, apakah ingin hanya di chat, apa mungkin mau menginfokan secara langsung? Oke, baik. Saya bacakan pertanyaannya. Izin bertanya, apakah GNSS meter ini real time dan dapat di-overlaykan dengan topo base map? Dan apakah ada contoh implementasinya? So, the question is this GNSS meter is real time and it could be overlaid with the topo base map? And if there is any implementation in anywhere, you could just maybe inform it. We can also this question is for Michal and also for Noval, I think. Yeah, Michal, time is yours.
Yes, this is real-time monitoring, meaning that you will get information about displacement as soon as it's being measured. Meaning that with a delay of few seconds of communication transfer from your gateway to your monitoring platform, you will obtain the information about the settlement. You will get this information based on hourly sampling. So every even hour you would have information about the formation. Now, in regards to the second question, to my understanding, this solution can be implemented into any third-party software, visualization software, that will allow to basically have this data being analyzed or displayed in the overlay of any georeferenced, I don't know, model. Now, Fal, can you help me out with this? Maybe you have more of an exposure to that.
Yeah, I want to add some information like untuk terkait real time monitoring pasti sudah jelas, karena memang dari yang dari telepati kami bawakan memang dihususkan untuk monitoring solution untuk real time, dan seperti yang tadi sudah dijelaskan oleh Michelle sangat jelas. Kita bisa mengkonfigurasinya tiap suatu periodik, jadi bisa paling tercepat hingga 1 menit, dan paling lama bisa 24 jam. Jadi itu disesuaikan lagi dengan kebutuhan yang memang diperlukan. Apakah memang kebutuhannya itu kerapatan datanya yang cukup tinggi, atau memang bisa dikonfigurasi pada 24 jam. Ya, that's it.
Mungkin Mas Novel bisa menjawab pertanyaan nomor 2, apakah mungkin bisa di overlaykan dengan base map?
Oh ya, untuk basement sendiri itu bisa, yang tadi sudah ditampilkan juga oleh Michelle dari CMTH, itu bisa ditampalkan dengan topografi, suatu suatu peta topografi. Kalau tadi Michelle contohkan itu dari Google Maps, dari nah sedangkan kalau yang kami mencoba bawakan itu bisa seperti tadi yang sudah sempat eh, saya present juga sebagai contoh, itu juga bisa ditambahkan di software T4D atau Trimble 4D Control. Nah, apabila di software T4D itu bisa dioverlaykan dengan berbagai peta maupun muatan data, dari Google Maps, dari TIFF apabila memang data petanya dalam berbentuk geotiff itu juga bisa, atau hanya sekedar foto itu juga bisa ditambahkan sebagai bantuan visualisasi ketika di lapangan secara 2 dimensi. Kurang lebih seperti itu.
Baik, terima kasih atas jawabannya Mas Noval. Semoga menjawab Bang Dani Panasius Paul dari Brokol. Dari rekan-rekan semua, apakah masih ada lagi pertanyaan terkait GNSS meter ini sendiri?
Izin mau cek-cek.
Ah, ya,
Ah,
silakan
ya.
Bang Dani.
Izin Mas Noval, Mr. eh, Michal, ya, dan Mbak Ruth ya. Makasih tadi penjelasannya bagus ya. Mungkin ini kendalanya gini, ini kan konsepnya agak mirip-mirip Extenso atau robotik total station ya. Ya, dan juga perkembangan jauh dari Prisma lah ibaratnya. Nah, kendalanya itu, saya mungkin menyampaikan kendalanya itu kalau di Brokol itu sekarang ada larangan memasang semacam prisma atau alat monitoring di area lereng gitu. Uh, itu yang menjadi kendala, makanya kita sekarang banyakkan menggunakan radar. Nah, ini kan sebenarnya menarik ya ini, tadi GNSS ini menarik. Nah, ini kalau dari tim apa ya, tim GNSS sendiri atau timnya eh, timnya Mbak Ruth ya. Ini bagaimana ya, ada ini nggak, mitigasi untuk pemasangan di lereng itu seperti apa gitu. Apalagi kan mungkin alatnya ya ibaratnya mahal ya. Jadi itu kan ibaratnya kalau ada failure itu otomatis kita harus merelakan ya ibaratnya. Mungkin bisa dijawab ya Mas Nova atau mungkin Mr. Mika.
Okay, so it seems like I would
Yeah,
like to. Oh
yeah,
yeah,
my
okay.
apologies. Translation, I would need to ask for translation.
Okay, so yeah, based on what Danny said that in their operation, so Mr. Danny is in one of the mining industries, and also using the monitoring technology as well, and they also have a comprehensive solution of the monitoring. So, but the challenge is they have face that their regulation right now is couldn't make like some solution that should supposed to be uh, on a slope. So yeah, that's why they are using radar to make it uncontactable monitoring. So, is there any solution of the slope monitoring, uh, like a prismless, maybe for the slope monitoring, just to giving the more solution of their challenges? This question is could be from your side, Michael, and also for Mr. Noval.
Yes, I would definitely have to bounce this question to Nafal. I would not be aware of any regulations and legislative recommendations, local recommendations by the Indonesian government and engineering institutes or governmental bodies. However, yes, the in terms of spatial monitoring, instead of monitoring the positions, there is probably about 5 or 6 technologies being utilized at the moment. One is automated total station, GNSS, terrestrial radar, the one that we already spoke about. There is as well a methodology of using INSAR photogrammetry, which are basically satellite obtained photographs. I wouldn't call that like this is regarded as a monitoring technology, or however, it's yes. And then obviously manual surveys. There's in terms of actually application for slope monitoring and spatial gaining to the XYZ positioning. uh, there is there is basically nothing else left, and just regular surveying, probably like a drone, short range drone flight, photogrammetry or modeling. However, these are just surveying methodologies. These are not monitoring technologies. And then please now, Fal, if you can elaborate on that as well, please.
Ya, menambahkan sedikit terkait pertanyaan dari terkait penggunaan monitoring solution suatu sensor yang mana yang berkaitan dengan uncontactable sensor, ya uncontactable sensing, yang mana dikarenakan adanya latar belakang policy atau regulasi dari site eh, untuk tidak menginstalasi dalam slope. Kalau untuk GNSS meter sendiri itu pasti kita pasang di titik yang dimonitor. Dan seperti yang tadi Bang Dani juga bilang, karena adanya resiko terkena longsor itu sendiri, atau ya justru titik yang dimonitor ini atau titik instalasi ini ya itu yang akan bergerak. Ya memang betul, karena untuk GNSS meter ini eh, sistemnya karena sudah titik yang diinstal adalah titik yang dimonitor. Ini mungkin ya salah satu ibaratnya konsekuensi juga dari instalasi GNSS meter, karena memang eh, sudah sistemnya titik yang diinstalasi adalah titik yang dimonitor balik lagi. Nah, sedangkan mungkin kami bisa memprovide opsi lain sebagai uncontactable sensor. Sebagai contoh yang tadi sudah dimention juga oleh Michelle terkait eh, radar yang sudah diimplementasikan oleh Bang Dani juga, dan INSAR, ya tadi juga sempat disinggung, atau yang biasa disebutnya eh, satelit yang ada di jadi kami dari Telematika itu juga provide terkait INSAR dari suatu brand bernama Skygeo. Di sini scanningnya nanti akan continuous juga dalam suatu lingkup yang besar. Jadi eh, massive area bisa di scanning dengan INSAR ini, atau yang interferometric synthetic aperture radar ini, kemudian akan menghasilkan data point cloud dan juga titik-titik deformasi yang didasarkan dari pixel yang disesuaikan kebutuhan. Jadi apabila berkaitan dengan INSAR, nanti akan berkaitan dengan pixel-pixel yang disetting, kebutuhan pixel atau resolusi yang berkaitan dengan resolusi dari si hasil dari data itu sendiri. Nah, selain itu dari sisi radar, kami juga provide dari Reutech. ini adalah salah satu brand dari South Africa dan juga kami berpartnership dengan yang di Australia. Reutech ini adalah salah satu radar juga yang mana memiliki eh, yang pasti akurasi yang sudah cukup tinggi dan juga ketahanan durability yang memang sudah bisa di eh, yang kompetitif dengan brand lain. Lebih seperti itu.
Terima kasih Mas Noval atas jawabannya. Dari Bang Dani, apakah ada tambahan?
Oke, mungkin cukup ya tadi sudah dijelaskan sama Michal dan Mas Noval ya. Terima kasih untuk penjelasannya.
Baik, terima kasih Bang Dani atas penjelasannya. Em, s- apakah masih ada lagi pertanyaan dari rekan-rekan semua terkait GNSS Meter? Mungkin sedikit menambahkan bahwa GNSS Meter ini merupakan salah satu teknologi monitoring yang memang bisa kita perkenalkan dan sudah dideploy di Indonesia di beberapa mining site yang sudah ada di Indonesia. Dan tadi sudah dijelaskan juga oleh Mas Noval bahwa em, dari GNSS Meter sendiri datanya juga memang bisa dikonsumsi oleh third party dashboard ataupun third party software yang nantinya bisa memberikan visualisasi yang lebih sesuai dengan apa yang menjadi kebutuhan dari kita sebagai pengguna. Dan Genesis Meter ini juga merupakan sebuah sensor yang ukurannya juga bisa dikatakan sangat portable dan mudah juga untuk dipindahkan. Jadi berbagai keunggulan-keunggulan dan fitur-fitur dari Genesis Meter ini ternyata juga bisa menjadi salah satu apa ya bisa dikatakan sebagai jawaban dari tantangan monitoring terutama untuk 3D ground movement. Um, jika tidak ada lagi pertanyaan, we would like to express our gratitude and also appreciation for Michal and also Sean. I think still on this presentation, on this loop right now. Thank you so much for your explanation dan dan terima kasih juga kepada Mas Novan Hair yang sudah memberikan penjelasan yang sangat komprehensif mengenai teknologi monitoring GNSS Meter di Indonesia dan juga beberapa monitoring solution yang bisa dikembangkan oleh PT Telematika Asset Monitoring. Dan sebagai reminder kepada rekan-rekan semua bahwa acara ini merupakan pre-event dari Indonesia Monitoring Summit yang akan diadakan pada tanggal 9 Oktober 2025 dan diadakan di Mercure Jakarta Simatupang. Di sini merupakan sebuah forum yang nantinya akan bisa menjadi wadah rekan-rekan sekalian dan akan berkomunikasi banyak sekali mengenai monitoring yang akan disusul juga dengan agenda workshop dan juga ada solution display di hari yang sama. Saat ini masih dibuka untuk pendaftarannya melalui telematica.co.id garis miring event atau bisa juga men-scan barcode yang ada di bawah. Acara ini merupakan kolaborasi antara PT Telematika Asset Monitoring dengan PT Sistem Solusi Geospasial sebagai authorized distributor dari World Sensing yang ada di Indonesia. Dan kami sebagai integrator untuk berbagai proyek, terutama untuk World Sensing Solution di Indonesia. Dan Indonesia Monitoring Summit sendiri memang merupakan disupport atau powered by World Sensing yang nantinya akan ada banyak um, representatif dari World Sensing. Mungkin kalau rekan-rekan nantinya sudah melihat di website Telematika, semua termasuk berbagai akademisi, profesional speaker juga akan mendukung di event ini. Nantinya harapannya event ini akan bisa menjawab tantangan-tantangan monitoring yang ada di Indonesia dan um, kita bisa mengarahkan ke future monitoring di Indonesia yang lebih baik. Sekian untuk webinar pada malam hari ini. Terima kasih banyak atas waktu dan kesediaan teman-teman dan rekan-rekan semua. Kami pamit undur diri. Terima kasih. Thank you so
Terima
much.
kasih. Thank you.
Selamat malam.
Thank you
Thank
for
you, thank
invitation.
you. Good night.
Selamat
Thank you.
malam.
Thank you.